Hey everyone, and welcome to another deep dive into the world of AI research. We've got a whole stack of fascinating papers hot off the press, so let's jump right in.
Sounds good.
So we all see those incredible AI-generated images and videos popping up everywhere, right?
Yeah, they're getting crazy realistic.
It's mind-blowing. But then you come across a paper like this one on the statistical capacity of deep generative models, and it kind of makes you pause. Like, whoa, hold on. Are there limits to what these models can actually do?
Yeah, that's exactly what this research dives into. And it turns out, even though these deep generative models can create these hyper-realistic visuals, they have a surprising weakness. They struggle with something called heavy tails.
Heavy tails. Okay, now you're just using fancy words to confuse me.
No, it's actually a pretty simple concept. Think about it this way. These models are great at capturing the everyday stuff, the average, but they struggle with the outliers, the extremes. Like,
Oh.
they can nail a photorealistic cat, no problem. But when it comes to predicting something rare, like a sudden stock market crash or natural disaster, that's where they stumble.
So it's like they're amazing artists, but maybe not the best at predicting the really unexpected stuff.
Exactly. And the researchers actually dug into the math behind this limitation using some pretty advanced concepts. But the takeaway for our listeners is that it highlights the importance of understanding the boundaries of AI right now.
That makes sense. So we're starting to see that AI isn't this magical, all-knowing entity. It has its strengths and weaknesses.
Absolutely. And that's why research like this is so important.
Well said. So how about we switch gears to something I find really fascinating? Making AI more transparent, more understandable. That's where I think this next paper, an explainable pipeline for machine learning with functional data, comes in.
Oh, this one's a good one.
So tell me about it.
This paper is all about making the AI's decision-making process clearer, especially when you're dealing with complex data that changes over time. Like, think about analyzing video footage or sensor readings.
So it's not just about the AI spitting out an answer, but also showing its work, explaining how it got there.
Exactly. They've developed a method called VISA that can actually visualize the why behind the AI's predictions.
And that's a game changer, right?
Huge for building trust in AI systems, especially in fields like healthcare or self-driving cars where the stakes are so high.
Absolutely. Imagine an AI system diagnosing a medical condition. You'd want to know why it came to that conclusion.
Right. Not just that it did.
So for our listeners, this means that as AI becomes more integrated into our lives, research like this is paving the way for systems that are not only powerful, but also transparent and accountable.
That's the goal, AI that we can understand and trust.
Okay, now get ready for this one, because I find this absolutely mind-boggling AI actually helping to develop other AI. This paper, Dataset Distillation as Push Forward Optimal Quantization, dives into that.
This is wild stuff. As AI models become more sophisticated, they need massive amounts of data to learn from, right? It's like a constant hunger for data.
A data feast.
But gathering that much real-world data can be a huge bottleneck. It takes forever. It's expensive. Sometimes it's even impossible.
So are you telling me these researchers have found a way to slim down that data mountain?
They have. They've figured out how to create smaller synthetic data sets that capture the essence of those giant data sets.
It's like a cheat code for AI development.
Kinda. It's like compressing a movie into just a few key frames that still tell the whole story. This dataset distillation could revolutionize how we develop AI.
Making it faster, more efficient, and maybe even leveling the playing field for researchers who don't have access to those massive data sets.
Exactly. It could democratize AI research and development, allowing smaller teams and startups to get in the game.
I love that. Okay, let's talk about another big challenge in AI research. Getting AI systems to actually reason logically the way we humans do.
Ah, yes, the reasoning puzzle.
Large language models like ChatGPT are amazing at mimicking human language, but they often struggle with complex reasoning tasks.
It's true, they can write you a sonnet or summarize a news article, but ask them to solve a multi-step problem or understand a complicated set of instructions and things can get dicey.
So they can talk the talk, but can they walk the walk when it comes to logic?
That's what researchers are trying to figure out. And this paper, Reasoning with Graphs, Structuring Implicit Knowledge to Enhance LLM's Reasoning, proposes a really interesting solution.
Using graphs, I'm guessing?
You got it. They're basically visual representations of relationships. And the idea is to use these graphs to help AI make those logical connections and deductions.
So it's like giving the AI a roadmap of how different pieces of information relate to each other, helping it see the bigger picture.
Precisely. And this has some really exciting implications for things like answering complex questions, controlling robots in challenging environments. You name it.
It sounds like we're moving towards AI that can not only process information but understand it on a deeper level.
That's the goal.
Okay, let's wrap up this first part of our deep dive with something a little closer to home AI's impact on healthcare. This paper, XvertNet. Unsupervised contrast enhancement of vertebral structures with dynamic self-tuning guidance and multi-stage analysis caught my eye.
This one's all about using AI to enhance the quality of X-ray images, particularly those of the spine.
I've heard about AI analyzing medical images, but enhancing them. How does that work?
Think about it this way. You have an X-ray image that's maybe a bit blurry or the contrast is low. This AI system can automatically sharpen the image, making it easier for radiologists to spot those subtle fractures or other abnormalities.
So it's like giving doctors an AI-powered magnifying glass.
Exactly. And this is just one example of how AI is transforming healthcare, leading to faster, more accurate diagnoses, personalized treatment plans, and even new drug discoveries.
It's incredible to think that AI could play such a vital role in keeping us healthy.
It's an exciting time to be watching this field unfold.
So we've covered a lot of ground in this first part of our AI deep dive, from the limitations of those dazzling image generators to the potential for AI to revolutionize healthcare, and we're just getting started.
There's so much more to explore, so stay tuned for part 2, where we'll delve even deeper into the latest and greatest AI research. Welcome back to our AI deep dive, where we're exploring some of the most exciting breakthroughs in artificial intelligence research.
I'm ready for more. What else have you got for us?
Well, let's stick with healthcare for a moment. There's a really interesting paper titled Boosting Sclerosegmentation Through Semi-Supervised Learning with Fewer Labels that caught my eye.
Sclerosegmentation. Okay, you're going to have to break that down for me.
Sure thing. So the sclera is the white part of the eye, and sclerosegmentation is basically the process of accurately identifying and outlining that white part in images.
Got it. So why is that so important?
It's crucial for a bunch of different medical applications, diagnosing eye conditions like glaucoma, developing new treatments, things like that. By accurately segmenting the sclera, doctors can get a much better understanding of the health of the eye and make more informed decisions about patient care.
That makes sense. So where does AI come into play here?
Traditionally, sclera segmentation was done manually, which could be really time-consuming and prone to error. This paper proposes using AI, and specifically a technique called semi-supervised learning, to automate and improve that process.
Semi-supervised learning. So it's like a blend of supervised and unsupervised learning.
Exactly. The AI is trained on a small set of labeled data, meaning images, where the sclera has already been clearly identified, but then it can apply what it's learned to a much larger data set of unlabeled images.
So it's like giving the AI a few examples and then letting it figure out the rest on its own.
Precisely. And this is a game changer because it significantly reduces the time and effort required for accurate sclera segmentation.
Especially in healthcare, where data can be so sensitive and difficult to obtain, this could be huge.
Absolutely. It could make these essential medical image analysis techniques much more efficient, accurate, and accessible.
I love that. Speaking of accessibility, let's talk about another challenge that often comes up in AI research training AI models with limited data. I'm thinking of this paper, MSc VIT, a small-size VIT architecture with multi-scale self-attention mechanism for tiny data sets.
Ah, yes. Trying to get those powerful AI models to work their magic with less data.
Exactly. So tell me about these VITs and why they usually need so much data to work well.
So vision transformers, or VITs, are a type of AI model that's become really popular for image-related tasks. They're known for their accuracy and performance, but traditionally they've required massive data sets to be effective.
And that's not always feasible, right? Especially for researchers or developers who are working with niche applications or just smaller data sets.
You nailed it. That's where this paper comes in. It introduces a new VIT architecture called MSc VIT that's specifically designed to be efficient with smaller data sets.
And how does it do that?
It uses a multi-scale self-attention mechanism that allows the model to capture different levels of detail without needing as much data to learn from.
So it's like teaching the AI to be a more observant student, able to pick up on subtle cues and patterns, even with limited information.
That's a fantastic way to put it. And this research has the potential to open up all sorts of new possibilities for AI applications in fields where data is scarce or expensive to collect.
Okay, now I'm always fascinated by research that aims to speed up AI processing, because who doesn't love things to run faster? Is there anything in this batch of papers that addresses that?
There is. Flash window attention. Speed up the attention computation for SWIN transformer focuses on optimizing a specific type of model called a SWIN transformer, which is really good at image processing.
And speed is everything when it comes to real-time applications like video analysis or self-driving cars.
For sure, Swin transformers use a technique called window attention, which basically breaks down the image into smaller chunks to make the computations more manageable. But even with this approach, processing high-resolution images can still be pretty computationally demanding.
Got it. So this research is about supercharging those wind transformers, making them even faster.
You got it. They've developed something called flash window attention, which is a souped-up version of window attention that drastically speeds up processing time.
And just how much faster are we talking?
Potential speed improvements of up to 300%.
Whoa. That's not just a speed bump, that's a speed warp.
It's a game changer. Not only does it make existing AI applications faster and more responsive, but it also paves the way for more complex models that can handle even larger data sets.
That's amazing. We've talked a lot about the incredible things AI can do, generate creative content, explain its decisions, even help develop other AI. But I think it's also important to step back and acknowledge that AI is still different from human intelligence. What are your thoughts on that?
That's a crucial point, and there's a fascinating paper, Divergences Between Language Models and Human Brains, that explores this very question.
And how did they go about comparing AI and human intelligence?
They use brain imaging techniques to look at how large language models like ChatGPT represent language compared to the human brain.
So they were literally peering into the brains of people and comparing that to how the AI models were functioning.
Exactly. And while there were some similarities, there were also some clear differences, particularly in areas related to social and emotional intelligence and what we might call common sense reasoning about the physical world.
So even though AI can produce really impressive human-like text, it doesn't necessarily understand the nuances of human emotions or the complexities of our physical world in the same way we do.
That's a key takeaway. It's a reminder that AI is a powerful tool, but it's still just a tool, and we need to be mindful of its limitations.
Well said. Now let's talk about a problem that's been getting a lot of attention lately: hallucinations in large language models.
Ah, yes, the AI equivalent of seeing things that aren't really there.
So what exactly does that mean when we talk about AI hallucinations?
It's basically when the AI generates text that's factually incorrect or doesn't align with the input it was given. It's like it's making things up even if it sounds totally convincing.
And that could obviously be a big problem if we're relying on AI for accurate information.
Absolutely. That's why research into addressing these hallucinations is so critical. The paper Addressing Hallucinations in Language Models with Knowledge Graph Embeddings as an Additional Modality proposes a really interesting solution.
Okay, I'm all ears. How do they suggest we tackle these AI hallucinations?
They propose incorporating something called knowledge graphs into the language model's processing. Think of a knowledge graph as a vast network of facts and relationships. It's like giving the AI a fact checker to help it stay grounded in reality and avoid making stuff up.
I love that analogy. So basically, by connecting the AI to this external source of verified information, it's less likely to go off on those wild tangents.
Exactly. And the researchers found that this approach significantly improved the factual accuracy of the language model's output.
That's really encouraging.
Yeah.
Okay, let's wrap up this part of our deep dive with one final area of research that I think is particularly fascinating: multi-objective reinforcement learning, or MORL.
Ah, yes, trying to get AI to juggle multiple goals even when they might conflict with each other.
Okay, so give me a real-world example of where this comes into play.
Imagine you're designing a self-driving car. You want it to be fast and efficient, but you also want it to prioritize safety and fuel economy. Those objectives might not always perfectly align, and that's where MRL comes in.
So it's all about finding that sweet spot where you're getting the best possible outcome across a whole bunch of potentially competing goals.
You got it. The paper, Pareto Set Learning for Objective Reinforcement Learning, introduces a really cool method called Pareto Set Learning, or PSL, for tackling these complex situations.
And what makes this PSL method so special?
It uses something called a hypernetwork to generate a whole bunch of different strategies for the AI to choose from, each tailored to a particular combination of objectives.
So instead of just having one strategy that tries to do it all, the AI has a whole toolkit of options to choose from depending on the situation.
Precisely. This makes the AI much more adaptable and capable of finding a wider range of solutions that represent those optimal trade-offs between those potentially conflicting goals.
This is all so mind-boggling. I feel like we've only scratched the surface of what's happening in AI research.
We've covered a lot of ground, but there's still so much more to explore. We'll dive into even more cutting-edge research in part 3 of our deep dive.
Welcome back to the final part of our AI deep dive. We've covered some truly mind-blowing research so far, from AI systems that can explain their decisions to AI that helps develop other AI. Now I'm really excited to see how all of this cutting-edge research is being applied to real-world problems.
Well, let's jump right in with a paper that takes us into the world of climate science. Fast, scale-adaptive, and uncertainty-aware downscaling of Earth system model fields with generative machine learning.
Climate science and AI. That's not a combination you hear every day.
It's a rapidly growing field, and for good reason.
Yep.
So Earth system models, or ESMs, are these incredibly powerful tools that scientists use to simulate climate and weather patterns.
I've heard of those. They're basically giant computer programs that try to capture the complexities of the Earth's climate system, right?
Exactly, but as you can imagine, those models require a ton of computing power. And even then, they often struggle with resolution. They can simulate those big global patterns, but have a harder time predicting local climate impacts with a high level of detail.
So how do we bridge that gap between the big picture and those finer-grained local impacts?
That's where this research comes in. It proposes using generative machine learning to downscale those ESM outputs.
Downscaling. So taking those global climate simulations and making them more detailed, more localized.
Precisely. And what's really cool is that this method can downscale to a resolution that's really only limited by the observational data you have.
So you could potentially take a global climate model and use it to make predictions about microclimates at a neighborhood level.
You got it. We're talking about more accurate, localized climate predictions, which could be incredibly valuable for urban planning, disaster preparedness, you name it.
It's amazing to see how AI is being used to tackle these big global challenges.
Absolutely. It really shows the versatility of these technologies. Now for our final paper today, let's shift gears to a topic that might seem a bit more abstract, but has profound implications for AI development: synthetic data generation.
Synthetic data, creating artificial data that mimics real data. Why would we need to do that?
It's a great question, and there are a couple of key reasons. First, sometimes real data is just hard to come by. It might be too expensive to collect, or there might be privacy concerns that limit access.
That makes sense.
Yeah,
Especially in fields like healthcare, where patient data privacy is so important.
exactly. Another reason is that real-world data can often be imbalanced, meaning certain categories are much more represented than others, and this can lead to biases in AI models trained on that data.
So if you're training an AI to detect a rare disease, for example, you might not have enough real-world examples to work with.
Right, synthetic data can help balance the scales, so to speak, by creating artificial data sets that represent all categories more equally, leading to more robust and fair AI models.
So how does the paper we're discussing today fit into all of this?
This paper, EPIC, Effective Prompting for Imbalanced Class Data Synthesis in Tabular Data Classification via Large Language Models, focuses on using those powerful large language models we've been talking about to generate synthetic tabular data.
Tabular data, so like the kind of data you see in a spreadsheet.
Exactly, rows and columns. And the researchers found that by carefully crafting the prompts, the instructions given to the language model, they could generate really realistic and balanced synthetic data even when the original data was highly imbalanced.
So it's like teaching the AI to fill in the gaps and correct for those imbalances.
You got it. This has enormous potential for improving AI training in all sorts of fields, especially those where data is scarce, expensive, or prone to biases.
We've covered an incredible amount of ground in this deep dive into the world of AI research, from limitations and challenges to groundbreaking solutions and real-world applications. It's clear that this is a field that's constantly evolving at a breakneck speed.
It's been a whirlwind tour, and it's important to remember that this is just a snapshot of what's happening at the forefront of AI research. New discoveries and breakthroughs are emerging all the time.
It's truly mind-boggling to think about what the future holds for AI and how it will continue to shape our world.
Absolutely. And as we wrap up this deep dive, I encourage you, the listener, to keep exploring, keep questioning, and keep learning. The world of AI is brimming with possibilities, and it's up to all of us to shape its future.
Thanks for joining us on this incredible journey into the heart of AI research. Until next time, stay curious.